Hey everybody, how's it going? Mr. Ince here. I just want to go through two different problems on our 8.1 notes that we started yesterday, or on Monday I should say. And I want to go through those two with you so that you're even further prepared for the review worksheet that you'll do next. So if you could please take out your 8.1 notes. We're going to knock out two of these, and I'll be expecting to see the work done and the completed answers for these in your notes packet when we turn them in for credit on the day of our test next week. So without further ado, here's our 8.1 notes. Ready, steady, go. All right, let me turn this thing around real quick. That's the wrong way. That's the right way. Okay, so remember, I'm on our 8.1 notes. This is the second page of it. So 8.1 notes, go ahead and flip over. I'm looking at problems within example 6, and we're going to go ahead and start with C. We were discussing this really specific situation that exists within right triangles. Again, our focus right now is on example C. So when you're working within a larger right triangle and you have this specific altitude drawn down from the original right angle, that altitude is the geometric mean. So let me go ahead and spotlight that real quick. That's the geometric mean between the two pieces of the hypotenuse that it breaks it up into. That piece would be this piece as well as this one. So when it comes to that work, as a general reminder, if something is the geometric mean, let's say that x is the geometric mean, a general way of expressing that would be a is to x as x is to b, where that x value is the geometric mean. In this question, this highlight is corresponding to this highlight. So I know that this could break down to 8 is to 5 as 5 is to the other piece. Okay? Notice that 5 is the geometric mean, and it's the geometric mean between this piece of 8 and this piece right here. Now, we need to carefully express this one. So notice that this piece, which ranges from here to here, it would be the entire length of m, but then we need to remove or subtract that 8. So again, all of this is m, but if I take away or subtract 8, this piece could more specifically be referred to as m minus 8. So I'm going to go ahead and put that expression in right here. Now that I've got this proportion set up, I can go ahead and cross multiply, but be careful here. You want to make sure that you block off these two terms in parentheses, and my multiplication would be 8 times the quantity of m minus 8 is equal to 5 times 5, or 5 squared. Taking it one step further, I'm going to distribute that 8 to both terms. So now I'm looking at 8m minus 8 times 8 is 64 is equal to 25. Now I'm feeling pretty good. Just seems like a two-step equation. So I'm going to go ahead and add 64 to both sides. That's going to cancel it from there. My next step, getting closer, 8 times that thing called m is equal to 89. And then finally divide by 8 on both sides. And that m must be equal to, you could list this as just 89 over 8, or it's going to go ahead and shake out to 11.125. Very precise. All right, second and last example that we're going to do in this video. Let's drop down to example G. Now, let's think about this. This one is a little bit more challenging because you have to ask yourself ahead of time, how am I going to find these different variables? We're going to need a little bit of room here to show some work. I know two different situations that we've discussed. I know that this piece, the altitude, is the geometric mean between these two pieces. But if I just tried to do that first, I would get x is to z as z is to y, and I would be so confused. Just looks like a bunch of letters at the end of the alphabet. I have no clue. Okay, I can't really advance in that question. The other scenario that we discussed, scenario number 2 in our notes, is that if you know one of the legs of that original right triangle, that that is the geometric mean between the piece that it comes in contact with as well as the entire thing. And for that, I can work with. I could go ahead and set this up as x is to 12 as 12, the geometric mean, is to the full piece of 16. Again, that was piece is to the mean as the mean is to the full. And once you have it set up, that is a reasonable proportion to solve for x. So I end up getting 16x equals 144. I'm going to go ahead and divide that down by 16 on both sides. Scratch, scratch. And I end up getting that x must equal exactly 9. Okay, so that's part of our answer. So we're feeling pretty good. We've got part of it. I'm going to return to the question. I'm going to list this piece as 9. Now I noticed that I kind of helped myself find two variables in one here, because we know that this y right here is the entire length of 16. Take away that 9. So this section right here has to be the full length of 16 minus 9, which shakes out to 7. So I'm feeling pretty good. So that y value must equal 7. So 2 down, 1 to go. The last variable that we need is that variable of z. Now let's remind ourselves that this piece, I'm going to go ahead and do this highlight in pink. This altitude is the geometric mean between the two pieces of the hypotenuse that it breaks. And for us, that piece is 9 and 7. So I could go ahead and set up a second proportion where piece 1 is to the mean as that mean is to piece 2. Keep in mind those are z's and that's a 7. Once I have that, it's a proportion with just one variable, so I can cross multiply, and I get that z squared equals 9 times 7 is 63. And then I can go ahead and square root, and that square root of 63 shakes out to a decimal that we're going to want to simplify. That z is approximately 7.94. Just to organize my info, this geometric mean was highlighted in pink, and our first geometric mean that allowed us to start the question was in yellow. Okay, so please make sure that you have those two things completed on your notes. Go ahead and start on the review worksheet that has been passed out, and I look forward to seeing everybody again